This is actually chapter number 2, reliability of a coherent system. I think we have already discussed the coherent system. What is the speciality of coherent system? What is meant by coherent system? ഒരു coherent system എന്ന് പറഞ്ഞാൽ എന്താണ്? A system consists of n components said to be a coherent system if all the components are relevant, and second condition is, what is the second condition? Increasing, phi of x is increasing in xi. So what are the points for the coherent system? System components are relevant. Okay, you know what is the definition of relevant. Second condition is system structure function is increasing. Okay, system structure function is increasing. So this is the two conditions for a system to be coherent. Now we consider, in the first chapter we have considered there are two possible values for a system and for a component. The state of the component and the state of the system are dichotomous. That means, what is the meaning of binary system? Yeah, system, the state of the component will be either working or either 1 or 0 according as whether the system is working, whether the component is working, whether the component is working or the component is in failed state. So there are two possible states, possible values for a component. They are 0 or 1. 0 means the component is failed. Okay, when component is failed, it will be denoted as 1. When component is working, then the value of xi will be 1. Similarly, for the case of system also. Okay, similar dichotomous property holds for the system also. So what will be the values? Yeah, system can be represented as, system structure can be represented as phi of some x1, x2, x3, xn. Okay, phi of can be phi of x1, comma, etc., comma, xn. Okay, system is a system structure is a function of component states. Okay, the system is also having two states, that is either failed or working state. Okay, now we consider in the first chapter we are not considering xi as a random variable. Okay, xi as a random, it will take either 0 or 1, it's a fixed values. Okay, and now we are considering a component state is a random variable. That means, yeah, there are two possibilities here, and 0, the probability, there is a probability associated with these values. That means we can, since it is random, if we consider this as a random variable, okay, we don't know actually at the time of inspection the component is working or not. Suppose you have put a light bulb on your room, you don't know whether this is working in next morning when you switch on this light bulb. So there is a chance for working as well as there is a chance for failing the component at the time when we switch on the light bulb. So there is a possibility for working or in failed stage when we inspect the component. Okay, so we can associate probability for the functioning and probability for the failed states. Denoted as P, let it be denoted as P probability of Pi equal to probability of xi equal to 1. Let us remove all these things. Xi equal to 1. So what is Pi? Pi is nothing but it is a probability. We are assuming the life of the light bulb is random. So in that case, in that case, we have to accommodate some probability assumption, and let p small pi is the probability of xi equal to, that means probability that ith component is working. Okay, ith component working. So so this is probability Pi, comma I can be any number between 1 and n. Okay, similarly, so since there is only two possibilities, what will be the complementary probability? Yeah, let it be denoted as Qi. Okay, we can denote the complementary probability as Qi because there is only two possibilities. What is Qi? Q is exactly equal to probability of xi equal to 0. What is said is failed. Okay, so there are two possibilities, and we are attaching some probabilities associated with these values. So this is the probability structure of component. Okay, now what will be the probability structure of, so since the components are random, component states are random, surely the system state will be also random. Okay, you don't know your computer will be working today, your mobile phone is working today. If you switch on the mobile phone or switch on your computer, it may be in functioning state or in failed state. Okay, so the system state will be also in will be also a random variable, since the components of the system is a random variable. So in this case also we can have two values, and we can associate probabilities with these two values. What are the probabilities? What are the probabilities? We can denote it as some h of, okay, let us denote later. This is probability of phi of x equal to 1. Okay, and there is this means probability that system is working. Okay, similarly we can accommodate the probability for 0. So what will be that? Yeah, it will be a probability of phi of x equals 0, that is system is failed. Okay, so there are two probabilities at the time of inspection, that is either system will be in working or in failed state. So in that case we can associate the chance for the working and failed stage. So we have four probabilities, Pi, Qi, and probability of phi of x equal to 1 and probability of phi of x equal to 0. So this is the notation. It is denoted as h. It is denoted as h. The notation given for this is h equal. So what will be this one? 1 minus h. Okay, 1 minus h. Now we have 4 values and 4 probabilities. Now what is expectation of xi? What is expectation of xi? Expectation of xi equal to, you know what is expectation of xi? X into probability of x equal to x. Sum over all possible values. So what are the possible values? 0 and 1. So what will be the expectation? What will be the expectation? Xi. What is the expectation of xi? Can you say? Anybody can say? Google Raj. Google.
Sir. Hello.
What is the formula for expectation, computing expectation? പഠിച്ചിട്ടില്ല. ഫസ്റ്റ് സെമ്മിൽ പഠിച്ചേതാ ഫോർമുല പറഞ്ഞാൽ മതി. ജോയൽ എക്സ്പെക്ടേഷന്റെ ഫോർമുല എന്താണ്? അതിന്റെ ഫോർമുല എന്താ? കമ്പ്യൂട്ടേഷൻ എങ്ങനെയാ? ഫസ്റ്റ് പഠിക്കുന്നല്ലേ? ഫസ്റ്റ് സെമ്മിൽ സെക്കൻഡ് സെമ്മിലൊക്കെ ഫർസ പറ.
Sir, summation x into probability.
Okay, about summation, here we have only 2 values. So I am not writing summation. So just x into its value. Okay, what is x into probability of xi equal to 1. Okay, plus 0 into probability of xi equal to 0. So this is the expectation formula. Okay, so what will be the result? 1 into p of xi equal to the 1 into probability of xi equal to, that is small pi, 1 into small pi plus 0 into small qi, that means just pi only. Okay, so this is the expectation. So but you know that what is pi? Pi is nothing but probability that it is working. That means it is known as reliability of component. What is reliability? Reliability is the probability that ith component is working for the component reliability. Component reliability. So that is reliability. So the comma which is reliability means വിശ്വാസ്യത എന്ന് പറയും മലയാളത്തിൽ. വിശ്വാസ്യത, the probability that ith component is working, so that is component reliability. Expectation of xi എന്ന് പറയുന്നത്. Okay, ith component reliability. Similarly, what will be the system reliability? System reliability is denoted as, so let us compute expectation of system structure. So what is that? Expectation of phi of, instead of x1 x2 x1 we write just x and we bold it. Okay, so that is expectation of phi of x. And moreover, you know that phi of x is also having two values, 0 and 1, and in that case we can write 1 into probability of phi of x equal to 1, okay, plus 0 into probability that phi of x equal to 0, because you have told me that this is the formula for computing expectation. So this is the formula. Okay, now we will simplify once again. So what is the value? Just this term only. Okay, other term will be goes to 0. So what is this? This is exactly h what we have written in the previous step. So this is h. So expectation of h is equal to this h. So this is the reliability. So this h is known as system reliability. That means probably that the system is working. Okay, so we have obtained two things. One is component reliability. Another one is, next one is component reliability. Another one is system reliability. Okay, so these are two fundamental concepts we are dealing with in this chapter. Okay, component reliability and system reliability. So actually what is component reliability? Actually component reliability, that is expectation of xi or pi. What is system reliability? What is system reliability? Expectation of phi of xi or h, that is probability that system is functioning. Component reliability is probability that component is functioning. Okay, I will save and send to you, no problem. Okay, I think you got the idea of component reliability and system reliability. Now we can consider two examples. Now we impose one condition, that is x1, x2, x3, xn are independent random variables, independent and identically distributed. We are imposing the condition that for the calculation purpose we are considering that, or we are considering the x1, x2, etc. xn are independent and identically distributed. What is meant by independent and identically distributed? IID. What is meant by independent and identically distributed? Let me ask to one among you. Rosmin.
Sir.
എന്താണ് ഇൻഡിപെൻഡന്റ് ആൻഡ് ഐഡന്റിക്കലി എന്ന് പറഞ്ഞാൽ?
Hello, sir.
What is meant by independent and identically distributed?
സാർ പെട്ടെന്ന് ചോദിക്കുമ്പോൾ കിട്ടുന്നില്ല.
ഇൻഡിപെൻഡന്റ് ആൻഡ് ഐഡന്റിക്കലി ഡിസ്ട്രിബ്യൂട്ടഡ് അറിയില്ലെന്നോ?
അറിയാം. കോൾഡ് ആയിട്ട് ഇരിക്കണം.
സാന്ദ്ര പറ, സാന്ദ്ര ഷാജു. സാന്ദ്ര, what is meant by independent and identically distributed?
ഇൻഡിപെൻഡന്റ് ആൻഡ് ഐഡന്റിക്കലി ഡിസ്ട്രിബ്യൂട്ടഡ് എന്ന് പറഞ്ഞാൽ അത്
പറഞ്ഞോ. It's a fundamental concept. കാവ്യ,
സർ
എന്താണ് ഇൻഡിപെൻഡന്റ് ആൻഡ് ഐഡന്റിക്കലി ഡിസ്ട്രിബ്യൂട്ടഡ്?
സാമ്പിൾ എടുത്തിരിക്കുന്നത് സെയിം പ്രോബബിലിറ്റി ഡിസ്ട്രിബ്യൂഷൻ ആണെങ്കിൽ ആണ് ഇൻഡിപെൻഡന്റ്ലി ആൻഡ് ഐഡന്റിക്കലി ഡിസ്ട്രിബ്യൂട്ടഡ് എന്ന് പറയുന്നത്.
കുറച്ചുകൂടി ക്ലാരിറ്റി വരാനുണ്ട്. ഇൻഡിപെൻഡന്റ് എന്ന് പറഞ്ഞാൽ എന്താ?
ഡിപ്പെൻഡഡ് അല്ല ബാക്കി ഒന്നുമായിട്ടും.
സ്റ്റാറ്റിസ്റ്റിക്കൽ സെൻസിൽ എങ്ങനെ ഇൻഡിപെൻഡന്റ് എന്ന് പറയാം?
സർ ഒന്ന് മറ്റേതിനെ സ്വാധീനിക്കുന്നില്ല. ഇപ്പൊ ഒരു നമ്മളൊരു ഡൈ ഇട്ട അതില് വണ്ണ് വരാൻ മറ്റ് 5 എണ്ണത്തിനെ ഏതോ ഇതാക്കുന്നില്ല, അങ്ങനെയല്ലേ? മനസ്സിലായില്ലേ?
തമ്മിൽ കണക്റ്റഡ് അല്ല സർ.
അല്ല, അതൊക്കെ നമ്മുടെ ഈ പറഞ്ഞ സ്റ്റാറ്റിസ്റ്റിക്കലി എങ്ങനെ പറയാ? when we say that x1 and x2 are independent,
they don't have a common relation.
അതെ, ഇൻഡിപെൻഡന്റ് വെർബൽ മീനിങ് ആണ്.
Okay, they are mutually exclusive.
അല്ല, എന്താ കാണുന്നേ? എന്താണ് കാണുന്നത്? പ്രോബബിലിറ്റി ഓഫ് എക്സ് ലെസ് ദാൻ സി കോമ y ലെസ് ദാൻ d is equal to probability of x ലെസ് ദാൻ c into probability of y ലെസ് ദാൻ d. ഓക്കെ, ശരിയല്ലേ? ഇതല്ലേ ഇൻഡിപെൻഡന്റ് സ്റ്റാറ്റിസ്റ്റിക്കൽ ഡെഫിനിഷൻ അല്ലേ? അങ്ങനെ കണ്ടിട്ടുണ്ടോ? ഇത് കണ്ടിട്ടുണ്ടോ ആരെങ്കിലും ഇങ്ങനെ? ഇങ്ങനത്തെ ഡെഫിനിഷൻ കണ്ടിട്ടുണ്ടോ? നിഖില് കണ്ടിട്ടുണ്ടോ? നിഖില്
അതേപോലത്തെ കണ്ടിട്ടുണ്ട് സാർ.
ഇപ്പൊ ഞാൻ എഴുതുന്നതാ? ഇത് കണ്ടിട്ടുണ്ടോ?
അടിയിലെഴുതിയിരിക്കുന്നത് എക്സ് ലെസ് ദാൻ സി. എവിടെ?
ഇത് തന്നെയാ താഴെ എഴുതിയേക്കുന്നത്. എക്ക് പകരം എക്സ് ലെസ് ദാൻ സി എന്ന് എഴുതി.
കണ്ടിട്ടുണ്ട് സാർ, കണ്ടിട്ടുണ്ട്.
അപ്പോൾ അതാണ് ഇൻഡിപെൻഡന്റിന്റെ ഒരു സ്റ്റാറ്റിസ്റ്റിക്കൽ ഡെഫിനിഷൻ. അതാണ് ഇൻഡിപെൻഡന്റ്. ഇനി വാട്ട് ഈസ് ഐഡന്റിക്കലി ഡിസ്ട്രിബ്യൂട്ടഡ്? what is probability of x less than or equal to എന്നാണ് ഞാൻ. ഫണ്ടമെന്റൽ ആണ് കേട്ടോ. അറിയാതെ നിങ്ങൾ ഡിഗ്രി പാസ്സാകുകയാണ്. So what is just probability of x less than or equal to c? What is probability of x less than or equal to c? This is the distribution function, I think. Is it right? Distribution function. Okay. Rihanna. If it is same as what is this? This is a distribution function of y. Okay. If f of c equal to probability of x less than c, that is same as probability of y less than c, that means f of c. That means f of c equal to g of c. That is x and y are having same distribution function. Same distribution function. Same distribution function we can compute every probabilities. Okay, like probability of x greater than c, like probability of a less than x less than b, etc. Using this distribution function we can compute every probabilities. So if the distributions are same, then probabilities will be same. That means identically distributed. That is the meaning of identically distributed. So if this random variables x1 next to xn satisfy this type of conditions, that is independent and identically distributed. Okay, then we can obtain the expectation or reliability. Okay, so for that we are considering an example of series system. We are assuming that x1 next to xn are independent and identically distributed. Okay, that means they are having same distribution for each and every random variable. So what is the structure function of series system? You know, structure function of the series system is nothing but that is product I from 1 to n, I equal to 1 to n, xi. Okay. Xi. This is the structure function of series system. So how can we represent? This is the structure function of series system. Now, what is the probability? What is the reliability? Reliability is nothing but probability of phi of x equal to 1. So we can find out the system reliability as probability of phi of x equal to 1. That means that you know that is expectation, because we have obtained the system reliability. Probability of phi of x equal to 1 is same as expectation of phi of x. So we can replace by instead of probability we can write it as, what is that, expectation. So what is this? You know, if x1 x2 xn are independent, we can take the expectation inside. Okay. So what will be the result? You know the result, that what is the result? Expectation of xy equal to expectation of x into expectation of y if x and y are independent. So that argument can be applied here and we can write like this. Okay, so what is this? Yeah, again we can write like this. What is expectation of xi? What is expectation of xi? That is pi, because we have already denoted that is pi. Okay, what is the system reliability of a series system? product I from 1 to n pi. So this can be obtained when x1, x2, xn are independent and identically distributed. Okay, since this step comes based on the independence assumption by, so let us by independence, by independence. Okay, so we have put only, and we will have one more step by identical assumption. What is that? Instead of pi we can use p, because they are identically distributed. All pi's will be same. Okay, so what will be the reason? Identically distributed. Okay, but you know that product I from 1 to n p, a constant multiplied n times, p into p into p into etc. What is that? P raised to n. If it is not identically distributed, we can stop with this step. If it is identically distributed, we have to go to this step also. Okay, I think you are clear with this idea. Okay, you got the idea? Similarly, for a parallel system, what will be the result? You know the result in parallel system. For a parallel system, suppose we are considering parallel system, then what will be the structure function? 1 minus okay, this is a structure function, so we can replace with this structure function this expression. Again we can take the expectation, because of independence we can take expectation inside. So what will be that? E bracket is okay. So by independence we can replace, so this is by independence. We can again take the expectation, just write pi. Okay, so if it is identically distributed, you can replace with p only. Okay, so what will be the value? 1 minus how many times? 1 minus p multiplied n times, so just 1 minus p raised to n. So this is the reliability of CD system, and this is the reliability of parallel system if components are independent and identically distributed. In between we can add out one more step here. One more step you can put here. What will be the step? Without doubt you can use this step also. What will be that step? Yeah, we will put first E here, and as a next step we will come to this step. Sorry, it is correct. It is correct. So this is not by independence, this is just property of expectation. Okay. So this is the steps involved for computation of reliability of CD system and Paris system. Okay, this is given here. Similarly, we can find out the K-auto system, reliability of K-auto system. Special cases are given here. You can look at these examples also. Now we will look the properties, some properties that will be discussed in the next class. No problem. Okay. Let us stop today's session, and I will send this Word file now itself, and the video you can use for your studies. Okay. Okay, thank you very much.